Welcome friends. The next topic of our presentation is inert cold gases. The carbon dioxide is an effective extinguishing agent. It is most often used in fire extinguishers that are available on the ramp to fight fires on the exterior of the aircraft, such as engine or APU fires. CO2 has been used for many years to extinguish flammable fluid fires and fires involving electrical equipment. It is non-combustible and does not react with most substances. It provides its own pressure for discharge from the storage vessels, except in extremely cold climates where a booster charge of nitrogen may be added to winterize the system. Normally CO2 is a gas, but it is easily liquefied by compression and cooling. After liquefaction, CO2 remains in a closed container as both liquid or gas. When CO2 is then discharged to the atmosphere, most of the liquid expands to gas. Heat absorbed by the gas during vaporization cools the remaining liquid up to 110 degrees Fahrenheit, and it's become a finely divided white solid dry ice snow. And the next one is dry powder system. Like class A, B or C fire can be controlled by dry chemical extinguishing agents. The only all-purpose class A, B and C rating dry chemical powder extinguisher contain monoammonium phosphate. All other dry chemical powder have class B, C according to US UL fire rating only. Dry powder chemical extinguishers best control class A, B and C fires, but their use is limited due to residue and cleanup after deployment. So the next one is water. As we all know that water is used for class A type fires, and it's best controlled with water by cooling the material below its ignition temperature and soaking the materials to prevent reignition. So this is all about the extinguishing agent which is used in aircraft. So the next one is install fire extinguishing systems. The first one is turbine engine compartment, where we used install fire extinguishing system in aviation. The first one is turbine engine compartments, the second one is APU compartment, the third one is cargo and baggage compartment, and the fourth one is laboratories. So the next slide is install fire extinguishers systems. In this the first one is install fire extinguishing system, in which including CO2 fire extinguishing system. Like older aircraft with reciprocating engines use CO2 as an extinguishing agent, but all newer aircraft designed with turbine engines use halon or equivalent extinguishing agent such as halocarbon clean agents. And the next one is halogenated hydrocarbon fire extinguishing system. The fixed fire extinguishers systems used in most engines, fire and cargo compartment fire protection system are designed to dilute the atmosphere with an inert that does not support combustion. Many systems use perforated tubing or discharge nozzle to distribute the extinguishing agent. High rate of discharge systems are used open end tubes to deliver a quantity of extinguishing agent in 1 to 2 seconds. The halon, the most common extinguishing agent still used today, is halon 1301 because of its effective firefighting capabilities and relatively low toxicity. UL classification of group 6 non-corrosive halon 1301 does not affect the material it contacts and requires no cleanup when discharged. This is all about the halogenated hydrocarbon fire extinguishing system. So the next one is containers. You can see here the image of container which is used in aircraft system for extinguishing the fire. Fire extinguisher containers store a liquid halogenated extinguishing agent and pressurized gas, typically nitrogen. They are normally manufactured from stainless steel. Depending upon design consideration, alternate materials are available, including titanium. Containers are also available in wide range of capacity. They are produced under Department of Transportation (DOT) specification or exemption. Most aircraft containers are spherical in design, which provides the lightest weight possible. However, cylinders shapes are available where space limitations are a factor. Each container incorporates a temperature, pressure sensitive safety relief diaphragm that prevents container pressure from exceeding container test pressure in the event of exposure to excessive temperature. In next slide you can see the nomenclature of the fire extinguisher containers. You can see here the number 1 engine container consists with explosive cartridge, relief vent to cockpit lights, pressure switches and gas, and this is gone to the number 1 per fire pool engine, as same as the number 2 fire container. So the next one is about the component of the container. So the first one is discharge valves. Discharge valves are installed on the container. A cartridge, which is called squib, and fusible disc type valve are installed in the outlet of the discharge valve assembly. Special assemblies having solenoid operated or manually operated seat type valves are also available. The second one is pressure indication. A wide range of diagnostic is utilized to verify the fire extinguisher agent charge status. A simple visual indication gauge is available, typically a helical Borden type indicator that is a vibration resistance. The next one is two-way check valve. As you can see in the image, two-way check valves are required in two-shot system to prevent the extinguisher agent from a reserve container from backing up into the previous empty main container, and valves are supplied with MS fitting configuration. And the next one is discharge indicator. Discharge indicator provides immediate visual evidence of container discharge on fire extinguishing system. Two kinds of indicators can be furnished. The first one is thermal and discharge. Both types are designed for aircraft and skin mounting. The next one is thermal discharge indicator. The thermal discharge indicator is connected to the fire container relief fitting and ejects a red disc to show when container's contents have dumped overboard due to excessive heat. The agent discharges through the opening left when the disc blows out. This gives the flight and maintenance crews an indication that the fire extinguisher container needs to be replaced before next flight. This is all about the thermal discharge indicator. Now the component of container. First one is yellow disc discharge indicator. This means if the flight crew activates the fire extinguisher system, a yellow disc is ejected from the skin of the aircraft fuselage. This is an indication for the maintenance crew that the fire extinguishing system was activated by the flight crew and the fire extinguishing container needs to be replaced before the next flight. The next one is fire switch. The engine and APU fire switches are typically installed on the center overhead panel or center console in the flight deck, as you can see in the image. When an engine fire switch is activated, the following happens. The engine is stopped because the fuel control shutoffs. The engine is isolated from the aircraft system and the fire extinguisher system is activated. Some aircraft use fire switches that need to be pulled and turned to activate the system, whilst the other use a push type switch with a guard. To prevent accidental activation of the fire switch, a lock is installed that releases the fire switch only when a fire has been detected. This lock can be manually released by the flight crew if the fire detection system malfunction. So, the next one is cargo fire detection system. Transport aircraft need to have the following provision for each cargo or baggage compartment. So the first one is the detection system must provide a visual indication to the flight crew within 1 minute after the start of fire. And the next one is the system must be capable of detecting a fire at a temperature significantly below that at which the structural integrity of the plane is substantially decreased. There must be means to allow the crew to check in flight the malfunctioning of each fire detector circuit. So the next one is